Hello everyone, welcome to Java tutorials. In this session, we look into various parameter passing techniques in Java. So Java supports two types of parameter passing techniques. First being call by value and second call by reference. Now let's first concentrate on call by value. So whenever you pass some primitive type of data to a method, it is passed by value. That means let us consider we have one class called demo. We create one class demo, and this class consists of one method called swap. Let us consider this swap method take two input parameters of integer a and integer b, and in this swap method we are changing the values of a and b, or doing some sort of operations on a and b. Let us consider we have a method main. Anyways, we'll declare this as public static void main and with parameter string array. Now in main method, we'll create a class of object demo. Let's consider we create object class demo as d equal to new demo. Let us also assume in class demo, or not in class demo, in method main, we are having two parameters of the same name as over here, a and b. So let us have some two variables of the same name. Even if the names are different, doesn't matter. Okay, let us say we initialize this value of a as 20 and b as a as 10 and b as 20. And let us call this function swap. Swap being a non-static function, we have created the object d of class demo. So we'll call upon this function swap by using the object d, and let us consider we pass the values as a and b. Now let us assume in this swap method the value of a and b is getting changed. Let's consider in that case a will become 20 in this method and b will become 10, whereas the initial values were 10 and 20. But now after the calling this function, if you are going to print the values of a and b, you will get a still remains 10 and b still remains 20. Now what happened over here? We are having two set of parameters. This a and b as your actual parameters, and these a and b which are given along the signature of the function, these are our formal parameters. Now even if it happens that the names are same, their memory locations are different. So we say the memory of a machine is in the form of a stack. So let me say this is the memory of the machine. All right, so while executing the program, definitely the entry point is going to be made. Let us assume if from this memory block, this block is associated with variable a and this for variable b, but this is for your actual parameters. Okay, so herein we change assign the values as a equal to 10 and b as 20. But now when you call the function swap by passing the values a and b, swap instead having its own variables a and b, though the name resembles the same as that of the actual parameters. What happens over here, different memory blocks are allotted. Now it might be possible this might be given to variable a and this might be for variable b. What is the memory location we do not know, but these are different memory locations. Here initial value passed was 10 and 20, and inside this function the values were changed, or let's say the values were swapped, and those become 20 and 10. That's what we are saying. In swap method, values of a and b are swapped. Now coming back to main method, when we are printing the value of a and b, we are actually printing the value of these parameters a and b, which are your actual parameters. Now values of a and b still remains intact. That means whatever we have done, the changes in this function, the function swap is not getting reflected back in the calling function which is calling the swap is main method. The changes are not getting reflected because memory locations are completely different. Now this method of calling or passing the parameters is said to be your call by value. Okay, so let's have one small example on this. So I'm using gedit as the editor. You can use editor of your choice. So here we go. We create a class named demo. Let's keep the same name as we have kept over here. Let me rearrange this first. Okay, I think this is sufficient. Okay, so name of class as demo, public class demo. Okay, and let me save this first. I've created one separate folder in which all the tutorials are added. So let's consider the name of class is demo.java. Yes. Okay. So now this class have one method named swap. So being a non-static method, we need to use like this public void swap, and this swap takes two integer as input parameters. As the name is swap, so let's consider we are going to swap the value. So let's have some temporary variable c. Then we say c is equal to a equal to b, and then finally b equal to c. So values of a and b are swapped. So you can check this thing. You can have one printf statement or system dot out dot println in swap function, or at the end of swap function. Let's have something like this. At the end of swap function, let me maximize this. Swap function. Okay, so let's consider backslash n backslash t a equal to, we'll print the value of a, and then let's have some space and say b equal to, then let's print the value of b. Okay, so that's swap method. Now let's declare our main method. Main method will declare it as public static void main string array args. We want to call upon this method swap. So swap being a non-static method, you need to create an object of class demo. So demo d equal to new demo. Okay, and let's have some local variables a and b. Let me assign the values here only instead of using assigning on the next line. Okay, int a equal to b, and let's consider we call upon the function swap. Okay, and we'll pass the values of a and b. Finally, let us print. Okay, let's execute this part first. So my location is just a second. Okay, here it is. CD desktop Java. Okay. So Java C demo.java. So no error. Now let's execute this Java demo. So you are getting at the end of the function val a equal to 20, b equal to 10. That's what we have done in the method swap. But now we want to check whether these values, that is a equal to 20 and a b equal to 10, whether this value remains there in main method. Okay, so let me just copy paste. Instead of writing all these things, here we say after calling in main method, after calling swap function. what is the value of A and B. Okay, so let me recompile. And now let's execute this. So here you get, understand. Initial value entry point is main method. So in main method, initially we are set A equal to 10, B equal to 20. Okay, then we are calling the swap method using object D, and we are passing A and B as your input parameters. Now here what's happening? Oh, where is the terminal? Okay. Yeah. When the call is given to swap method, we are getting the values A is 20 and B as 10 because the values have been swapped as per this logic. C equal to A equal to B, and B equal to C. But this change is not getting reflected back in our original method, that is your main method, because whatever the variables those are created, whether those are formal variables and actual variables, they do not share the memory location. They have the separate memory locations. So what we have say, only the values are passed. So when you are calling the swap method, value of A as 10 is passed and value of B as 20 is passed. So this is what we said to be called by value. Now let's consider we are going for call by reference. Reference means it basically resembles the address. Okay, and in Java, if you are gonna to use objects as a parameter, okay, then situation changes, because objects are passed by what it is effectively called as call by reference. Okay, let's have a small example on this. You will get to know in a couple of minutes. Just hold on. Let us say we create another class. Okay, before that, let's have some theoretical aspect over here. What we are going to have is we'll create class. Let's consider class demo ref. So because previous name was demos, let's have this as demo ref. And this class is having two class variables, int A and B. Let us assume we are initializing these values by using a constructor demo ref. It will take two integer parameters, int x comma int y, and then let us say A equal to x and B equal to y. Okay, we'll have one method. Let's consider the name of that method as print. Let us say void print. But this method print is gonna to take a parameter which will be the object of class demo ref. Demo ref. Let's consider name of object as P. And in this, let's say we change the value of variable A of object P as A equal to whatever it may be. Let's consider we write 50, and similarly of B as 70. Finally, we'll go with main method. We'll use the same logic while doing the program. In main method, okay, we'll create an object demo ref. Let's consider we create an object R, and let me use some shortcut over here. Okay, no need of shortcut. Let's consider we pass the value as 10 and 20. Okay, then let us say we call the method demo ref, or else you can print the value system.out.println, and let's consider you're gonna print the value of A and B. So you'll get the value of A and B as 10 and 20. But now what we'll do, we'll call upon the method print. Okay, now to call upon the method print, hold on, where it is missed. Okay. To call upon the method print, we'll use the object R because it's a non-static method. Okay, but to this, we will pass R itself. What is this R? R is a object of class demo ref. And what's this print request as an input parameter? As object of class ref. Now here we are saying object name as P, and here what we are passing the object as R. Okay, and after this, let us then again reprint this statement. We'll print the value of R, A and B of object R. Okay, and then we'll cross check whether these values of A and B has been updated or still remains same as 10 and 20. So based on this, let's create one class. Let me have this side by side so that a coding and this theoretical part goes side by side. Rearrange this. Hold on. Okay. Something I need. Just a second. Okay. Okay, going ahead. Public class demo ref. Okay, so let me save this name, copy it, and let me save this file. I'll save it in the same folder so that while executing, we won't change that directory over there. Okay, demo ref. So this demo ref is having two class variables, A and B. Okay, and one what do we say, constructor. This constructor is a parameterized constructor taking two integer values, and these values are then assigned to class variables A and B. So A is assigned the value of X and B is assigned the value of Y. Okay, then our method print. So public void print, and this print takes an input parameter which is going to be the object of class demo ref. Okay, so demo ref, let's the name of the object be P, and here we change the values of variable A of object P. Let us be 50. Let me say not change, let me say we are assigning the value to variable A of object P as 50 and variable B of object P as 70. Okay, that's it. Then coming to the main method, we'll have the standard structure: public static void main string array args. Okay, just let me elaborate this. Okay, that's better. And over here, whatever we are gonna do is first we create the object of class demo ref. Let's consider name of object as R. I'm keeping the same whatever we have written over here. R equal to new demo ref. To this we'll pass the values as 10 and 20. Let us say whether the values 10 is 20 is assigned to A and B. So for that purpose, what we'll do is system dot out dot println before call. Let's say let me maximize this. Before call A is equal to plus A, and let's skip some space. B equal to, let's say, B. Okay, let us first cross check whether this is working. So again, let me clear the screen. So let's recompile. Our name of file is demo ref javac demo ref dot java. Oh, something wrong. Yes, I don't have variables A and B as local variables. Those are class variables. So I need to use this as r dot A and r dot B, because these are class variables. I need to use the object of this, and these are non-static variables. These are non-static, so if I would have declared a static int a and b, then writing a and b would have been accepted, but these are non-static, so I need to use the object. So I have written just as r dot a and r dot b. Okay, so let me save this first. Yes, it's saved. And now let's recompile. Yeah, it worked. Let me clear the stuff. It's very bulky. Okay, Java C demo ref dot Java. Now let's execute Java demo ref. Yes. Before call, a is equal to 10 and b equal to 20. That's proper. That's what we have assigned. Okay. Now we'll call upon the method print. So print is a non-static method, so we need to use object r dot print, and we need to pass object. Let the object be r itself. Okay. And after that, we'll again print the values of a and b. So let me copy and paste. Right. Okay, but here we'll only change after call. Analyze the name of the parameters. The parameter is r. Again, it's an object of class demo ref. It's acting as a actual parameter, and formal parameter is again the object of the same class demo ref. The name is p. Okay, let me save it, and now let's execute this. Not execute. Let's recompile this first. Yes, it worked, and now let's check out over here. Oh, something got changed. Before call, the values were 10 and 20, but after call, what's happening? It's 50 and 70. But while we are changing the values, we are changing the values of not object r, we are changing the values of object p. If you look into here, we are passing object r as a parameter, accepted, and while receiving, that means the actual parameter named as p, and we are changing the value of p as 70 and r a as 50 and b as 70. This is what actually happens when you create a variable of class type. You are basically creating a reference to a object. Thus, when you pass this reference to a method, the parameter that receives it will refer to the same object as that referred by the argument. So even if you are passing object r, since r is a reference, so that reference r can be also be used by parameter p. So basically we say the object remains the same, the memory location remains the same, but those has been referred by two different variable names, p and q. Thus, when we pass this reference to a method, whether we are passing the reference what r, okay, we are passing the reference r. The parameter that receives it will refer to the same object. Parameter का नाम क्या है? P. Over here, the name reference parameter is what? P. Now, this will refer to the same object as that referred by the argument. Due to this, objects are passed to the methods by use of call by reference. Hence, any changes to the object we do inside the method. Object is what? P. What are the changes we'll do to object P inside the method? Which method? Method print. This will get reflected to the actual object in the calling function. Calling function is what? Main. What was the name name of the object over here? R. So whatever the changes we do over here, it will get reflected in R as well. Because of which, even though we are saying we are changing only the values of variables of object P, it also means we are changing the values of object R. So though we make the change in a demo print or in print method, the same changes are reflected in your calling method. So this is what we say, call by reference. Okay, that's it for this session. In the case you all liked it, then hit the like, share, and subscribe. Thank you.